Hello everyone, welcome back. We're gonna take a look at section 2.4, which is the last section for chapter 2. So in this section 2.4, we're gonna talk about symmetry. Okay, so what's the symmetries and what's gonna be why we need to know the symmetry. Okay, so symmetry occurs often in nature and in art. So for example, let's take a look at the butterfly over here, right, everyone? So for example, when viewed from the front, the bodies of most animals are at least approximately symmetric. So this means that each eye is the same distance from the center of the bridge of the nose, and each shoulders is the same distance from the centers of the chest, and then so on. So you can see the symmetric over here, right? So you can take a look at the butterfly. It's gonna give you the ideas of symmetric. Yeah. So a knowledge of symmetrics in math help us to graph and analyze equations and function. Okay. So algebraically, because we do in math over here, so algebraically, so how can we know the symmetric for the graph of in the graph and then the equation, right? So function and equation. So how we can determine if an equation or the graph of function will be symmetric. So let's take a look at the algebra test over here for symmetric. Okay, so this is the algebra step. We can use in this concept over here to determine if a graph or if an algebraic equation or a function will be symmetric. Okay, so let's take a look at the algebraic test of symmetric or symmetry. Okay. So there are three different kinds of symmetry that we're going to take a look. The first symmetry we're going to talk about is symmetric with respect to the x-axis. The second symmetry that we're going to talk about is going to be the symmetric with respect to the y-axis. And then the third one is going to be symmetric with respect to the origin. Okay, so x-axis, y-axis, and the origin. So let's take a look at the first case, everyone. We're going to talk about the symmetric with respect to the x-axis. So how we determine if a graph or if an algebraic equation will be symmetric with respect to the x-axis. So if replacing y with the negative y produce an equivalent equation, then the graph is symmetric with respect to the x-axis. Okay, so you're gonna replace y with the negative y's and it produce an equivalent equation. So we're gonna get a symmetric with respect to the x-axis. Okay. Now let's talk about the symmetric with respect to the y-axis, everyone. Okay, so if we replace an x by negative x, okay, so if we replace x by negative x, it's producing equivalent equation, and we're gonna get equivalent equation, then the graph is symmetric with respect to the y-axis. Okay. So that's the second symmetry that we have, y-axis. Now the third symmetry that we're gonna have is gonna be the symmetric with respect to the origin. So if replacing y by negative y and replacing x by negative x produce an equivalent equation. So you're gonna get the opposite of y, replace y by negative y, so replace x by negative x, produce an equivalent equation, then the graph is symmetric with respect to the origin. Okay, so this is the algebraic method that we can use it to determine if a graph is symmetric with respect to the x-axis, y-axis, or the origin. So most of the case, we're gonna use this concept over here when the question gives you an equation, right? So that's it. Most of the time, we're gonna use this idea to double check if an equation is symmetric with respect to the x, y, or the origin. Okay. So let's take a look at the graph first. It's gonna give you the ideas of the symmetric with respect to the x, y, and the origin. So I have these three examples over here. The first graph over here is an example of symmetric with respect to the x-axis. Okay. So the first one over here, I'm gonna say it's gonna be symmetric with respect. Yeah. So symmetric with respect to x-axis. Okay, so WRT with respect to x-axis. Okay, so you can see that it's gonna be symmetric with respect to the x-axis over here, right? So you can see the top half of this graph is gonna be a mirror of the bottom half, or the bottom half over here will be a mirror of the top half, vice versa over here. So when you randomly pick a points on top portion of the graph over here, there will be a reflection of that point along the x-axis. Okay, so this is symmetric with respect to the x-axis. Okay. Now the middle example, so over here, I'm gonna say that's gonna be symmetric with respect to the y. So symmetric with respect to y-axis. Okay. So you can say that, yeah, so you can see that the portion of the graph on the left-hand side is over here gonna be a mirrors of the portion of the graph on the right-hand side is over here. So when you pick any random point on the left-hand side of this graph over here, you will see a reflection of that point along the y-axis on the other side of the graph. Okay, so when you randomly pick any point on the left-hand side of this graph, you will see a reflection or you will see a mirror along the y-axis on the other side of the graph. Okay. So now the third example, so over here, the third graph over here, you can see that I'm gonna use in this example to show the symmetric with respect to the origin. Symmetric with respect to the origin. Okay, so this is an example of symmetric with respect to the origin. So gonna be, look like the bottom half over here, so gonna be some mirrors of the top half with respect to the origin over here. Okay, so whenever you pick a point, any random points on this portion on the left-hand side of the graph over here, you will see a mirror along the origin on the other side of the graph. Okay. So those are the three examples of symmetric with respect to the x-axis, y-axis, and the origin. Okay. So this is the graph over here. So you can base on the graph to determine if we have a symmetric with respect to the x-axis, y-axis, or the origin. Okay. So we're gonna talk about something about properties over here. Okay. So what's the point in terms of the points over here? So what they're gonna be? Okay. So when we have the symmetric with respect to the x-axis over here, for example, when you pick a point x and y. Okay. And then you will have this point. It's gonna be x comma negative y. It's gonna be on the other side of the graph. It's gonna be a reflection of this point along the x-axis. Okay, so the point x comma y will have the reflection x comma negative y on the other side of the x-axis. Okay. Now for the second symmetry that we talk about over here, or symmetric with respect to the y-axis, if you have a point x and y, then there will be some reflection. The reflection will be, what's going to be the reflection? The reflection will be negative x comma positive y. So x is going to be the opposite. Okay, so this is the two ordered pairs of points. That's going to be symmetric with respect to the y-axis. It's going to be a mirrors along the y-axis. Okay. Now, how about the third case over here when we talk about symmetric with respect to the origin? So for example, when you pick the first point x comma y, you will see a reflection of that point is going to be in term negative x comma negative y. Okay. So in terms of any general point, this is how they're going to relate it with respect to the x-axis, with respect to the y-axis, and with respect to the origin. Okay. So we have the ideas of the symmetric so far, right? Symmetric with respect to x, y, and the origin. Now we're going to do some more practice question based on the algebraic test of symmetries over here. So if you want to determine if a function, if an equation is symmetric with respect to x, y, or the origin, we're gonna base on the three summaries over here to determine if what kinds of symmetry we're gonna get. Okay. So let's take a look at the first question over here. So test y is equal x squared minus 3. So they're gonna give you this equation over here, y is equal x squared minus 3. So for symmetry, yeah, so test this equation for symmetry with respect to the x-axis, y-axis, and the origin. So we're gonna test for each of them. Okay. So we're gonna do the first one with respect to the x-axis. The second one is going to be y-axis. And then the third one is going to be the origin. Okay, so for the first one, how we determine if this equation gonna be symmetric with respect to the x-axis. Okay, so we're gonna go back to the summaries over here. For the x-axis over here, we're gonna replace x, but we're gonna replace y with negative y's and produce some equivalent equation. If this is true, then we have the equation, or yeah, equation will be symmetric with respect to the x-axis. Yeah, so x-axis we replace y with the negative y and see if we have equivalent equation. Okay, so for the x-axis we replace y by negative y. Okay, so for the x-axis over here, we're gonna replace y with negative y. Let's say with negative y. Okay. Okay, so now originally we have y is equal x squared minus 3. Now we're going to replace y by the negative y. So negative y is equal x squared minus 3. So most of the time we don't want to get the y's in negative in front of y's over here, right? So we will divide both sides over here by negative 1. So when you divide both sides of this equation by negative 1, now we're going to get negative x squared and then plus 3. Okay. Now you're gonna negative x squared. Sorry, I forget the negative. So we have negative x squared. Now we're gonna compare the original equation that the question gave you right here, and let me pick some color. And the equation that we just have right here, are they equivalent? Are they look the same? Okay, so the original equation and then the new equation over here, are they equivalent? No, they not look exactly the same, right? So they're not the same. So it means that we don't have equivalent equation. Yeah, so when you replace y with negative y and we don't have equivalent equation, then no. Okay. So we can say that not symmetric with respect to the x-axis. Okay. Okay, so this equation is not symmetric with respect to the x-axis. Okay, so that's the first case. Now, similar concept over here, we're gonna check for symmetric with respect to the y-axis. So for y-axis, what we need to do? Okay, so for y-axis over here, we're gonna replace x with negative x. And hopefully, if we have equivalent equation. Okay, so once again, we're gonna replace x by negative x. Okay, so let's see if that's going to be true or not. Okay, so I'm going to copy the original equation first. So x equal y is equal x squared minus 3. Now I'm going to replace x by negative x. So y is equal negative x to the power 2 minus 3. So y is equal, when you take a negative number raised to the power 2, the answer will be positive, right? So negative x to the power 2 is going to give you x squared minus 3. Okay, so now when you compare the original equation and the equation that we just got after replacing x by negative x, right? After we replace x with negative x, are they equivalent? Yet they look equivalent, exactly the same, right? So the original equation and the new equation that we just got are exactly the same. So yes, it's gonna be symmetric with respect to the y-axis. Now, the third case over here, we're going to check for the origin over here. So how can we determine if this equation is symmetric with respect to the origin? So let's take a look at the summary one more time for the origin. We're going to replace y with negative y and replace x with negative x. Okay. So replace y with negative y and x with negative x. And then we're going to double check if we will have equivalent equation. So once again, original equation, we have x squared minus 3. So this is the original equation. Now I will replace it. I will replace y by negative y, and I will replace x by negative x. Okay, so negative y still the same, nothing changed. Negative y still stay negative y. But when you take negative x raised to the power 2, negative x, a negative number raised to an even power, the answer will be positive. So gonna give you just x squared and then minus 3. And once again, I don't want to get the negative in front of the y's over here, so I will divide both sides of this equation by negative 1. So we have y is equal. Y is equal, what is it going to be? Negative x to the power 2 and then plus 3. Okay. Now, once again, we're going to compare the original equation that we have originally, right? And the new equation that we just got after we replace y with negative y and x with negative x. Are they equivalent? No, right? They're not equivalent. So, okay. So because they're not equivalent, so we're going to say that they're not symmetric with respect to the origin. Okay, so far so good, everyone. Let's see how we determine if an equation is symmetric with respect to the x-axis, y-axis, or the origin. So by just some basic substitution and simplify and determine if we have some equivalent equation. Okay. Okay, so the summary is over here. So make sure that you're going to take a look at that whenever you see some similar question. If you want to determine if an equation is symmetric with respect to x, y, or the origins. Okay. Okay, so this is the first question. I have some practice. Oh, let's try another one together. Okay, right. Okay. Now it's going to be similar concept over here. We're going to do 3 different cases. So we're going to test this equation for symmetric with respect to the x-axis, y-axis, and the origin. Okay, so the first case we're going to do is going to be x-axis, and then it's going to be y-axis. I'm going to show the real quick over here first before we try it, and then it's going to be the origin. Okay, so for the x-axis over here, we're going to replace y with negative y, right? That's what the summary indicates. Okay, so I'm going to copy the original equation first. This is my original equation. Okay, now I will go to this equation. I will replace y with negative y. Okay, so we have x squared, same thing, plus. Now y will be replaced by negative y. Negative y to the power 2 is equal 4. Okay, so x squared still the same. When you take a negative y raised to the power 2, the answer will be positive, right? So it's going to be y squared equal 4. Okay, now you're going to compare the original equation and the equation that we just simplified it right here. Are they equivalent or are they identical? Yes, they are equivalent, right? So yes, it's going to be symmetric with respect to the y-axis, okay, or to the x-axis first. Okay. Okay, now the next one, we're going to test if this equation is symmetric with the y-axis, okay. So if you want to determine if an equation is symmetric with respect to the y-axis, we're going to replace x with negative x, right? Okay. Okay, now let's see. We have the original equation, x squared plus y squared is equal 4. Now I will replace x by negative x. Okay, so we have negative x raised to the power 2 plus y raised to the power 2 is equal 4. Now, whenever you take a negative number raised to the even power, negative x raised to the power 2, the answer will be positive. So we have just x squared plus y squared equal 4. Okay, so that's good. Now you're going to compare the original equation that we are given originally and the equation that we just got right here after we simplified it by After we replace x by negative x and simplify it, they look exactly the same or they are equivalent. Okay, so you're gonna say yes, we have symmetric with respect to the y-axis. Okay. Now the last portion over here, we're gonna check for the origin over here, right? So anyone remember how we're gonna check for the origin? We're gonna replace what? Replace x with negative x and y with negative y. And let's see if we have equivalent equation. So once again, I'm gonna just look like print out the original equation, leave it there. And now I'm gonna do is replace x by negative x. And I also replace y by negative y. So once again, whenever you take a negative number raised to the even power, the answer will be positive. So we're going to get x squared plus negative y raised to the power 2. So going to give you y squared equal 4. Okay. So let's compare the original equation and the equation that we just have over here after we simplified it. They are equivalent, right? So what's your conclusion? So yes, it's going to be symmetric with respect to the origin. Okay. Okay, so far so good, everyone, right? Okay. So we directly using the summary to determine if an equation is symmetric with respect to the x-axis, y-axis, or the origin. Okay. And I have one more question over here for you to practice, everyone. This is your turn to try it. Let's give it a try. Okay. Now, the next portion that we're going to talk about on this section 2.4, after we know how to determine if an equation is symmetric with respect to the x-axis, y-axis, or the origin. Now we're going to talk about even and odd function. Okay. So even function and odd function. So how can we know if a function is even function and how can we know if a function is odd function? Okay, so let's take a look at the definition. Okay. So if the graph of a function f is symmetric with respect to the y-axis, yeah, it's going to be symmetric with respect to the y-axis, then we're going to say that it is an even function. Okay, so if you have a function f is symmetric with respect to the y-axis, then that function is an even function. Okay. That's it. For each x in the domain, we have f of x equal f of negative x. Yeah, so f of x equal f of negative x. Okay. Okay, so that's the even function. Now let's take a look at the next definition, odd function. Okay, so if the graph of a function f is symmetric with respect to the origin, okay, it's gonna be symmetric with respect to the origin. We're gonna say that the function is even, odd, sorry, yeah. So if it's gonna be symmetric with respect to the origin, we're gonna say that this is an odd function. That's it. For each x in the domain, we have f of negative x equal f negative f of x. Okay, so f of negative x equal negative f of x. Okay, so this is how we determine if a function will be odd or even. Okay, so you can base on the symmetric property that we have earlier, right, everyone? If we know if a function is symmetric with respect to the y-axis, it's gonna be an even function. If it's gonna be symmetric with the origin, it's gonna be odd function. Okay. Okay. Now we're gonna use this definition over here to determine to answer the next question over here. So we have 3 examples over here. I'm gonna try the first 2 and your turn to try the last one. Okay, so for the first one over here, question A. So determine if each of the following function is even, odd, or neither, right? Okay. So we're not gonna show if this function is even or gonna be odd. So okay, so how can we know that? Okay. So one of the possible way that you can base on the symmetric, that's the symmetric property that we worked earlier. to determine if this function is if this function is even or odd over here, right? So that's one of the possible ways you can base on the symmetric property that we have on the previous portion of this, or you can base this on this case over here. If you can prove that f of x equal f of negative x, then it's gonna be even. Okay, so I'm gonna use in the new condition over here, right here, f of x equal f of negative x. Okay, so I'm gonna evaluate f of negative x, and I want to see if they're gonna give me the answer equal f of x. Okay, so I will evaluate f of negative x. Okay, so what does it mean by f of negative x? So f of negative x is mean that the input will be replaced by negative x over here. So let's see what we're gonna get. Okay, so I'm gonna get negative x raised to the power 5 minus 3 times negative x raised to the power 3 and then minus 7. Okay, so now let's see what we're gonna get, everyone. F of negative x equal. So when you have a negative number raised to an odd power, the answer will be negative, right? So still a negative. So we have negative x to the power 5. Now, when you have a negative number raised to the power odd, which is power 3, it's gonna give you negative. So we're gonna get negative 3 times negative x to the power 3, right? And then minus 7. Okay, nothing changed. Now let's keep going, simplify that as much as possible. Now we have negative x to the power 5, nothing more, that's on. But the middle term over here, we're gonna get negative 3 times negative x to the power 3, a negative times a negative positive, so it's gonna be positive what? It's gonna be positive 3 x to the power 3, right? And then it's gonna be negative 7. Okay. Oh, this is f of negative x. Okay, so now we evaluate f of negative x right here, so everyone. Now we're gonna compare with the original. Are they look the same? So if that's f of negative x equal f of x, is it true? No, right? So this is f of x. Let me copy the f of x over here so you can compare, that's easier. Okay, so this is the function f of negative x, and we have f of x over here. So we can know that f of negative x is not equal f of x, right? Because the term is not matching. So this is negative, positive, this is negative, positive. Okay, so that's good, right? Okay, so f of negative x is not equal f of x. Okay, so this is your first conclusion. So we have f of x not equal f of negative x. So if this condition is not true, right? So it's not an even. So not even. Okay, so this function is not an even. Is it an odd function? Okay, so if you want to determine if this function is an odd function, you have to check the third condition over here. How about f of negative x equal with negative f of x? Okay. Now, let's evaluate negative f of x. Okay. What's the negative f of x? So negative f of x, that means we're gonna take the negative for the original fx right here. Okay, so let's simplify this over here, everyone. Okay, so we're gonna get the negatives right here. Yeah, let's distribute these negatives over here. Okay, so we're gonna get negative x to the power 5. A negative and a negative is gonna be positive. So it's gonna be positive 3 x to the power 3. And then a negatives and a negative is gonna be positive 7. Okay. Now we're gonna compare the f of negative x and then negative f of x. Are they the same? Okay. So we have f of negative x is this one. And now we have negative f of x right here. And they look the same. The first term match, the second term match, but the last term doesn't match, right? Okay. So because the third term doesn't match, so what's your conclusion? So we can say that f of negative x not equal. So f of negative x right here, f of negative x. Okay, so we have f of negative x, and then is it equal with negative f of x? So this is f of negative x right here, and this is negative f of x. So you can see that they're not exactly matching, right? So no, okay. So they're not equal. So f of negative x not equal negative f of x. So this is not odd. Okay. So this function f of x, not even function, not odd function. So it's gonna be neither, right? So okay, this is your final answer. It's gonna be neither, right? Okay. Okay, now let's try question B. So obvious, everyone, let's try it together. Okay. Okay, so we're gonna try question B together again, everyone. So it's gonna be similar with the step-by-step we did with question A, right? Okay. So we are given the function g sub x over here. So this is just, I just name it differently. So the function g sub x, right? So x to the power 4 minus 2x squared plus 4. Okay. So we're going to determine if this function is even or odd. Okay. So once again, you can base on the symmetric property that we have earlier, or you can base on the calculation right here in this on this page. So now I will calculate, let's see. So g of negative x. Okay, so I will evaluate now to the function g of negative x. Okay, so now g of negative x, it means that the input will be replaced by negative x. So we have negative x raised to the power 4 minus 2 times negative x raised to the power 2 and plus 4. Okay. I'm gonna take this question to the next page so we have enough room to show it. Okay, so now let's simplify this function. So we have g of negative x equal. When you take a negative number raised to an even power, the answer will be positive, right? So we have x to the power 4 positive. Now minus 2. And when you take the negative x raised to the power 2, it's even 2, so it's gonna be positive. So we're gonna get x to the power 2. And then plus 4. Okay, let's simplify it without the parentheses. So g of negative x equal x to the power 4 minus 2x squared and plus 4. Okay. So we just evaluate g of negative x over here. Now we're going to compare g of negative x and g of x. Are they matching? So g of x equal x to the power 4, good. Negative 2, x to the power 2, good, and plus 4. So we can see that g of negative x equal g of x. Let's see, g of x, yeah. So we can see that g of x equal g of negative x. Okay. So because we just showed that g of x equal g of negative x, so we can say this is an even function. So we have even function. Okay. So this function is even already, right? Okay, so we check for even. Now, if you want, you can check for look like it's gonna be an odd function. We'll see. But usually, if a function is already even, it's not gonna be odd. Okay, so but let's see. Now we're gonna check for the function if it's gonna be odd, so I will evaluate negative f of x. Okay, so I will evaluate negative f of x. Negative, actually negative g of x, right? So negative g of x means that we have a negatives of the function g of x right here. So negative g of x equal, it's going to be negative x to the power 4 plus 2x to the power 2 and then minus 4. Okay. So this is negative g of x. Okay, so we have negative g of x is that answer. How about g of negative x, right? So this is f of negative x and then negative f of x. So just instead of using f, we just replace it by g. So we're gonna compare f of negative x and negative f of x. Okay, so f of negative x, where is it? G of negative x is this one. This is g of negative x. And we have negative g of x. Are they matching? No, right? They're not matching. Yeah. So we have g of negative x right here, g of negative x. And we have negative g of x. They're not exactly matching. Okay. So we can say that g of negative x is not equal with negative g of x. Okay. So g of negative x we have earlier and negative g of x, they're not exactly matching. So this is not odd. Okay. But we already have the conclusion, right? This function is an even function. Yeah. So most of the time a function could be even or odd. Yeah. So if a function already even, then usually you don't have to bother to check about odd. It's already even, so it's not gonna be odd. Okay. So this is just in case, right? Now we have the third example over here. You can try it, everyone. Okay, so this is going to be your turn, your actual practice over here, part C. That determines if the function h is even or odd or neither. Okay, so this is the conclusion of chapter 2 or section 2.4. So this is the last chapter that we need to cover for chapter 2. So we on turn with chapter 2, so everyone. We finished section 2.4, last section for chapter 2. Okay. So this is on done from chapter 2. I'm going to see you next time. So next time we're going to talk about chapter 4.